Hello everyone, my name is Jae-hoon Lee. I'm currently working as a professor and chairman at Prosthodontic Department at Dental School in Yonsei University. It is great honor and privilege to share my research findings with you today. The topic I'm going to talk about today is surface functionalization in dental implant. Some of you here today maybe never heard that implant is getting old, just like human being. I know it is a very difficult concept, but it is getting old. Implant surface is getting old. The implant surface are losing its viability, biological activity as time goes by, and we call that biological aging in implant. So today, I'm going to talk about what the biological aging of titanium implant is and how we can overcome this problem by using surface functionalization. Everyone in this room knows how important the process of osseointegration is for the successful implant restoration. To increase the success rate and enhance initial stability of osseointegration in very predictable manner, surface modification has been researched and evolved for the several decades. But there are still mysteries. For example, why implant to bone contact cannot exceed 60%. To explain, I'll go into a little more detail about molecular biology of osseointegration. Bone formation, in other words, osteogenesis can be divided into distance and contact osteogenesis. Like I said, bone formation has two different processes. One is growing from the bone, and the other is growing starting from the surface of the implant. It will eventually take over by woven bone, but this growth on the titanium surface, contact osteogenesis, is very important to achieve proper implant to bone contact and also good initial stability. Okay, I'm gonna show you very short video clip to explain possible reason for that occurrence. Upon implant surgery, there will be hemorrhage and many cells and cell proteins will be released. And they will have a contact with the titanium surface upon the surgery. And those cell proteins and cells on the titanium surface will provide all the sources for the bone growth and osseointegration. Mesenchymal cells, which is a stem cell, will land on the surface and it migrates and differentiates into the bone, forming osteoblasts, and it becomes eventually osteocytes. Therefore, how many of these cells and protein can successfully land, maintaining its activity, proliferation, and spreading is very important for the osseointegration process. So, favorable circumstances and characteristics of the titanium surface is very critical for the osseointegration. I'd like to explain one very important phenomenon, the character of the titanium implant. After titanium is milled for manufacture, it will become covered by oxide layer in very shortly, like in nanosecond. This oxide layer is the one that binds with the cell protein and extracellular matrix to achieve successful osseointegrations. But one phenomenon that we overlooked in the past was the oxide layer will be contaminated in a nanosecond, and this contamination will be increasing as time goes by. So eventually, its bioactivity and also good properties will be diminished. Again, when oxide layer get contaminated, its bioconductive properties will be degraded. So because of its bioactivity is diminishing for the cells and cell proteins, we call that biologic aging of the titanium implant. Year 2013 or 12, Dr. Ogawa in UCLA and myself studied and gathered information about biological aging of the titanium process and published. The picture on the right hand side showed the changes of the wettability in titanium surface, and you can see as the time goes by it becomes more and more hydrophobic. When you drop the water on the surface of the titanium, you can see more roundish droplet of the water on the aged surface, which showed higher contact angle with the surface. So if that is a very new surface, then water angle is very high and it looks more like roundish. But as time goes by, it becomes more flat, which is more hydrophobic. Okay, this is a very simple evidence. Then we test measuring the carbon atom percentage on the titanium surface, and because the carbon is a major source of contamination of the surface, measuring the amount of the carbon and surface is a good parameters of the contamination. After treatment of single etching of the surface, it was 26.74%. After 2 weeks, the percentage increased up to 32%. After 4 weeks, it reaches up to 35%. From this study, we can conclude after manufacture of the implant, the surface will be contaminated by carbon as time goes by, which is not favorable and degrade the bioactivity of titanium surface to the bone cell and its cell protein, so which eventually negatively influence the osseointegration processes. This biological aging process cannot be explained by only hydrophilicity, but many other characteristics of titanium surface like albumin absorption, cell attachment, and cell proliferation, and differentiation, and mineralizations. And all this kind of good property will be diminished. So there are a lot of evidence of biological degradation of titanium surface to the cell and cell protein in vitro levels. Okay, this is my first article experimenting to prove the biological aging on in vivo level. My graduate student and myself published this article in 2018. So we use acid etching, which we intend to mimic the manufacturing process of an implant, so that we can make it just like new fresh surface, and then gave time interval to 0 and 2 weeks to compare with the one manufacturer longer than 6 months. So we use 6 young dogs were used in this experiment, and mandibular premolar on both sides was extracted, and 2 months after the extraction, the implant were placed. This timetable shows the interval, which was 0, 2 weeks, and 6 months since manufacturing of the implant, and we measured the BIC, implant bone to contact, in 4 and 12 weeks after implant installations. The result shows that there were statistically very significant difference between group of 6 months after manufacture versus newly prepared and 2 weeks old implant at 4 weeks of healing time. So we were able to prove that the biological aging of titanium will degrade the osseointegration process. Okay, now we have a concrete evidence that the time affects the bioactivity of the titanium surface. So then, what could be the possible solution for that problem? To answer this question, I'm going to discuss about photofunctionalization. This is the short video clips. Okay, source of this photofunctionalization is a UV light. So when you use UV light irradiation to the titanium surface, it will change the whole property of the titanium surface. So you can see as received titanium, photofunctionalize the titanium, you can see the wettability is significantly increased. So on the left hand side is a very old one, and after photofunctionalization it becomes very hydrophilic. So you can see the increasing hydrophilicity. So this is another pictures. It shows the changings. So this is a machine that we use that was manufactured a company called Ushio in Japan. So this is how the chamber look like, and each chamber has the light source, and it gives the irradiation to the implant surface. Okay, nowadays there is many UV light irradiation products are available in the market. Especially in Korea, there's so many copies, but they don't have enough backup data. Some company says they invent this machine for the first time, but that's not true. The fact that the UV light could change the characteristics of the titanium surface was first introduced in 1997. So this phenomenon was called photocatalyst, and that was applied to many industry. A good example would be a painting material. Paint include titanium particles will evaporate the organic contaminants upon UV light irradiation from the sun, and it produces ozone under the UV light so that it cleans and kills the bacteria on the surface. By the same theory, if you irradiate UV light to the dental implant surface, hydrocarbon and all the carbon sources which cause the contamination will be eliminated, and it become more hydrophilic, and more importantly, it become positively charged for the surface of the implant, which is much more favorable to the cell and cell proteins. So it will restore bioactivity of the titanium surface for the osseointegration process. When removing the hydrocarbon from the titanium surface, photolysis creates the electron hole pair because of electron in the valence band of the semiconductor, which transition to the conduction band. This phenomenon causes the generation of surface oxygen vacancies and reactive oxygen species. As a result, the titanium becomes more hydrophilic, favorably positively charged with a less hydrocarbon. So this diagram shows negatively charged aged surface which repel the cell protein versus on the right hand side positively charged one that attract the cell proteins. So as a result, on the left hand side, aged surface will bond with a bone cells by inorganic bridge for osseointegrations. on the right hand side, if you see, UV treated one will end up with a direct bonding with a bone cell and cell protein. There are many articles published in the past providing photofunctionalization effect on the titanium implant. But there was no in vivo study using big animal to prove this photofunctionalization effect at that time. Therefore, for the first time, I did a in vivo study experimenting UV light effect on titanium implant that was published year 2013. I'm going to briefly introduce this study. 6 male dog was used and sand-breasted acid etching surface implant was used. And this is the one that I showed you earlier, machine. The name of the machine is a TheraBeam Affinity, were used for the UV light irradiation. A 15-minute irradiation were operated. And this shows the machine look like. And you have seen these short video clips, right? And this is a picture after the surgery on the dog. The teeth were extracted and socket were healed for 2 months and an implant was installed. The first thing that we did was the measuring and comparing removable torque between using implant that were placed on the maxilla. Removable torque is a requiring force to remove implant from the bone. So the UV tested group showed superior removal torque forces compared to the control groups, which means much more strong osseointegrations. We also observed marginal bone sealing effect for the UV treated groups. So for the functionalized group, we observed very consistent intact marginal sealing on the top portion of the alveolar bones. But in the left-hand side, untreated one, there is some kind of collapse of the bone. And bone-to-implant contact was also superior in the UV-treated group in all 3 zones, cortical, bone marrow, and marginal zones. Bone volume was also superior in UV-treated groups. Another important finding of this study is a coefficient of variance on BIC and VV bone volume was very low in UV treated group, which means there was not much difference between data on UV treated group, which means the result was very consistent, which means effect of UV was very consistent as well. And interesting aspect of this study was we used fluorescent agent so that we can observe new bone formation much more clearly on the titanium surface. You can see, compare on the test group on right hand side, UV groups, you can see very clearly dying fluorescent agent, which means more active bone formation on the surface of a titanium implant on the UV treated group. Same thing. On the right hand side, you can see the green fluorescent agent shown much more clearly, which means there was much more higher level of the bone formations. So to summarize this study, removable torque, bone to implant contact, bone area, bone volume was higher in UV treated group, and there was also marginal bone sealing effect on UV treated groups. Next, I'd like to share my clinical study that was performed on implant patient of Yonsei University Dental Hospital from 2015 to 2018. That was published this year. This is the first clinical study for this to see effect of photofunctionalization in Korea. Total 80 implants were placed in the patient's posterior maxillar area because we intend to compare the effect of UV where you cannot have a good initial stability. So 40 implants were used for the control, and another 40 was used for UV tested group. When we placed implant, we performed without informing the surgeon which one was UV treated or not, in double-blind manner. So IHQ value for stability and bone loss around the implant were measured for different time to compare. Immediately after surgery, 4 weeks, 4 months, and 1 year intervals. And there was statistical differences at 4 months as well. It concluded the UV irradiation was very effective for the early bone formation and early stage of osseointegration. So it will be very useful for the use where you cannot have good initial stabilities like posterior maxillar or bone graft area. So this study will be published and then could be a very strong evidence for the use of this photofunctionalization device. So now I like to talk about the non-thermal plasma method to compare with the UV photofunctionalization, which is I want to compare with the plasma effect with the UV photofunctionalization. Plasma can be used, and it is very depending on the gas being injected, but it is generally composed of free electrons, ions, free radicals, and chemically reactive neutral particles, and also UV and various visible light. These free radicals and energetic ions are distributed on the titanium surface, and several reactive oxygen species change the surface of titanium to be hydrophilic. This is my plasma study that was performed in year 2015. I like to see if non-thermal plasma would have a very similar effect as a UV light irradiation. So we place 41 SA implant to 6 dogs and sacrifice at 4 and 8 weeks after implant placement. Result shows a statistically significant difference at 4 weeks after implant placement. So I was able to come to the conclusion that either UV or non-thermal plasma, as far as it gives enough energy to the surface of the titanium surface, it deactivates the surface of the titanium implant. I like to say it is rejuvenating and to the degraded surface. So it restores the bioactivity of the titanium implants. This non-thermal plasma has several advantages. If you use it in a dental use, it can be used in the patient's mouth to remove the plaque, and you can also use for the endodontic sterilization, and even to exposure the implant surface due to bone loss around the implant by peri-implantitis. It doesn't cause any kind of heat, so that for the dental use there will be a lot of advantages that we can take for the dental treatment. Okay, I like to summary my presentation in a very 3 different aspects. First, I like to point out scientific implications. Why this is so important? We've been kind of neglect this kind of biological aging properties of dental implants, which means all the study that we have done so far, we didn't really consider biological aging of titanium implants. So we didn't really, this aged titanium surface has never been standardized, and very recently start to describe in several literatures in the field of dental research. So I believe more studies in the future to compare different surface for this biological and osteoconductive potential, and also it may require standardization of age of the samples, or careful interpretation of the research outcome will be required. So we have to reorient our studies about dental implant so far. And second thing is, I like to say another important aspect of this study is the clinical implication. I like to say time to pay attention. In fact, there was no regulation or exploration of manufacturers because we didn't know this implant surface will be aged as time goes by. So when you distribute this implant after manufactures, you need to take care of it, how old it is, and how much long time that was restored in the storage. So you want to have also exploration of the sterilization, and also some other aspect of regulation for this aging process. So it will be very practical for the implant product that delivered within 4 weeks after manufacturing. Or if you use this photofunctionalization device to rejuvenate the surface, it will be very helpful, I believe. So time-related substantial degradation of bioactivity of titanium shows draw and impending attention for exploring potential clinical implication and possible solutions. Lastly, when you use this photofunctionalization device in your clinics, there are many surface functionalization device available in the market. Last 4 to 5 years, for good example, in Korea, there is so many products is available nowadays. But thing is, none of them they have their own investigation or experiments, and what would be the ideal, let's say, wavelength, or how long irradiation, how many times irradiation will be the, let's say, ideally remove these carbons and so on. So they all, most of them are only just copy of the original one. So when you purchase these machines, you should also consider whether they have enough backup data, or if they have some experiments saying, okay, this product was designed after properly done experiment, so on. So I like to say, before you use this kind of device and machines, right, you also see the backup data and what kind of background of this machine that you're gonna use in your clinic. So again, photofunctionalization process will rejuvenate your aged implant surface, but when you use it, you should be very careful which one to use. So I like to wrap up my presentation with summary. Time-dependent degradation was substantial in that the strength of osseointegration is greatly reduced compared with a newly prepared titanium surface. So I share with you some of study of mine that was done with UV and plasma. And both UV and plasma irradiation result in very optimized cell environment on titanium surface. Both of them restore the bioactivity of the titanium implant. So upon continuing research to improve surface functionalization device, more rapid and complete establishment of the osseointegration will be possible in near futures. So I will be continuing my research on the this area of the study so that I will try to make it much more shorter and much more effective device can be possible. I'd like to thank you for your kind attention, and if you have any questions and comments, please email me to the address that you can see in the bottom of my slide. Thank you very much.